Hi, everybody. It's nice to be here, or it would be nice to be here if I was actually there instead of here up in my attic. And oddly, though, I've spent the last 8 months continuously on Zoom. It feels like it's the first time I've recorded a talk. Ones I've done before, I've done live. So I hope you bear with me, and I hope I can get this right. What I'm going to talk about today is the relationship between behavior genetics generally, and particularly twins, and what I call mainstream social science. And I'm happy to come to a twin conference, but what I have to say mostly I think applies to modern DNA-based genomics just as much as it applies to twins, and that's kind of an interesting topic that I probably won't have time for. And it kind of starts with my own intellectual history with this stuff. I've been a skeptic in many ways about the meaningfulness of the outcome of twin studies for a long time. If you know much about what I've written over the years, I'm prone to argue that heritability per se doesn't really mean very much, that it's omnipresent, it doesn't tell you how genetic something is, that the familiar terms that come out of behavior genetic models, A, C, and E, have a lot of other meanings than the traditional literal genes and environment. And I've even gone so far as to say there's no point in doing more simple heritability studies. And that often led to a question when I would say that, sort of, okay, smart guy, if we can't do our twin studies anymore, what should we do? Is behavior genetics over? And no, I don't think it is. And I'm a twin psychologist myself and a behavior geneticist. So this talk is really about how can you use twins once you give up on heritability. And the core message is that most human psychology, at least of the kind I do, if you're not an experimental psychologist, is about trying to infer causation from non-experimental data. Developmental psychology in particular, and most of the studies I'll talk about are developmental, not all of them. Experimental control is usually impossible. So we observe correlations out in the world. We observe that some characteristic of parents is correlated with some characteristic in children. And what we wonder is that relationship causal? And so the way I see twin studies is as a tool to try and infer causation from correlation and non-experimental data. We talk about quasi-experimentation and quasi-causation, which are very old concepts in psychology, where psychology has a lot of roots in randomized experimentation. And in the 50s and 60s, scientific psychology was moving away from traditional lab-based brass instrument kind of psychology to more work out in the field. And it led to a lot of problems of how can we do valid causal inference on these kinds of data. And there were books written, Campbell and Stanley, that I was raised in grad school on, about quasi-experimentation, which are imperfect but practical ways to infer something like causality from non-experimental data. I always like to start with this example. Not my own study, it's getting to be kind of an old study, but an example of the kind of correlation that you can observe in the world is the correlation between breastfeeding of children and various characteristics in the kids. And people always want to know, is breastfeeding good for children, or is not breastfeeding bad for children? And in particular, people have sometimes thought that breastfeeding might be related to cognitive development and even to adult intelligence. And this study was by a bunch of Danish researchers who found a data set that had recorded how many weeks of breastfeeding children had had, and then their adult IQ. So they set about looking to see whether there was a correlation between how long these people were breastfed and their eventual intelligence. And sure enough, there was. In the lowest group, there was a mean IQ of 98, and then at least in the 7 to 9 week group, a mean IQ of about 110, which is, a 10-point difference, which is no small thing. But of course, the problem is causality and knowing whether the breastfeeding is actually causing the increase in IQ, because children are not randomly assigned to breastfeeding conditions. And the mothers who choose to breastfeed are different in all sorts of ways from mothers who don't breastfeed. Among other things, they're richer and better educated. And so that could be confounding this relationship in a non-causal way. Well, it turns out that the National Longitudinal Study of Youth, a big population-based study in the US, has the same data. It has weeks of breastfeeding and IQ actually in kids, not when they're adults. And it has one additional piece of information. It has multiple children per mother. It has 3,000 children to 1,800 mothers. So there are siblings in the design. And mothers don't breastfeed all of their children the same length of time. So that allows us to do a very particular kind of analysis between mothers and within mothers. The between mother analysis is about averages. The mothers who breastfeed longer on average have children who are more intelligent on average, whereas the within mother is about deviations within families. Are the siblings who are breastfed longer more intelligent than the siblings who are breastfed less? And you get a very interesting result. Between parents, averages to averages, you replicate the Danish effect. 1.5 IQ points per 10 weeks of breastfeeding accounts for 6% of the variance. Within mothers, on the other hand, there's nothing at all. There's no tendency for the kid who's breastfed longer to be smarter than the kid who's breastfed less. Now, what do we make of that? Well, I think it's intuitive that because children are not randomly assigned, it's a little bit deceptive to talk about what we're observing here as breastfeeding. It's not just breastfeeding. What we're observing is breastfeeding and between mothers, everything that's correlated with breastfeeding between mothers. So that is, for example, socioeconomic status and maternal education, and heaven knows what else. Hundreds of variables that we don't measure that differ among breastfeeding and non-breastfeeding mothers. Most of those confounding variables are controlled within mothers because it's the same mother. It's a fixed effect model. And so to the extent you see the effect between, but you don't see the effect within, what does that tell you? It tells you that the effect is coming from the confounds, it's not coming from the breastfeeding. We've spent the last 20 years in our twin lab identifying interesting correlations out in the world and then seeing how they hold up in twins. And a cool thing about doing this is that it turns out that most of developmental psychology and other kinds of psychology is waiting to be redone in a more causally informative way. Some very quick examples, because I don't have a ton of time. One interesting correlation out there is between step parenting and menarche. Age of menarche in girls. It turns out that girls who are exposed to a stepfather tend to have earlier menarche than girls who are raised by their biological father. That's a well-known observation. It's a correlation. And it has as usual, girls are not randomly assigned to step-parent conditions. So there's a causal question. Why does that happen? Is it that step-parenting causes early menarche? There are hypotheses about why it happens. Early menarche is mostly correlated with negative things. I won't worry about that. In the adolescent health data set in the United States, they have information on step parenting and menarche in children. This is what's called a children of twins design. It's actually the mothers who are twins, not the children. So you can compare identical twin mothers, one of whom had a stepfather in the family and the other one did not. One mother remarried to a stepfather, the other didn't, and compare the daughters in those families. Now, between families, as before, you see the effect. That is, overall, girls raised by stepfathers had 6 months earlier menarche than girls not raised by stepfathers. But when you look inside the discordant families, that is, families where one mother had the stepfather, the other mother did not have the stepfather, there's no difference in menarche between their daughters. So once again, that shows that the effect happens between families, not within, which suggests it's a matter of some kind of confound, and later parts of the investigation are about identifying that confound, rather than anything specifically and causal about the stepfathering. Another interesting one, also from adolescent health, that I did with Paige Harden. This was a study that was published by a couple of sociologists about the Adolescent Health Project, showing that girls who in wave 2 of ad health had initiated sexual activity younger were more likely at wave 3 to be engaging in delinquent behavior. These sociologists gave it a hard causal interpretation and said, well, we should have programs to prevent kids from initiating sex too early so that they're not at risk for delinquency. And same story. When you look at it within twin and sibling pairs, the effect completely goes away. This is between where the girls on the right who started sex early are more delinquent. Within pairs, that is the sister who starts sex early more likely to be delinquent than the sister who starts sex late. Not only does that effect go away, there's a significant effect in the opposite direction. We don't really know what that means. But there's no evidence for a causal link between timing of first sex and delinquency. One more, this one not a developmental study, one a little more recent that I did with some colleagues at the Washington State Twin Register, a big community-based sample of twins in the state of Washington, about an old nutrition problem, epidemiological nutrition problem, about trying to show that soda consumption is related to BMI. And sugary sodas obviously have a lot of empty calories in them. They ought to be related to BMI, one would think, but it's very, very hard to show. Why? Because people aren't randomly assigned to soda conditions. Right? People who drink a lot of soda are different in a zillion ways from people who don't drink a lot of soda. That's just descriptive data. I haven't talked much about it. The identical twin correlation is higher than the fraternal twin correlation for both BMI and soda drinking, just like it always is. And this is the more numerical as opposed to graphical way we order the data. On the bottom line labeled BP, these are the unstandardized regression coefficients relating BMI to how many soda portions you have a day. And it's a substantial and significant effect, about a unit of BMI per additional soda a day. But on the other hand, when you, in the quasi-causal model, control for twin variables, which is essentially doing it within pairs, the effect gets as much attenuated, is no longer significant, and I mean, it doesn't quite go to zero, but it gets very, very small. So once again, what looks like a causal association out in the phenotypic world doesn't look so causal when you look at it within twin pairs. What does all this mean? Behavior genetics isn't about estimating heritability. I just gave an entire, if fast, talk about BG without mentioning heritability at all and presenting my results. These models were capable of estimating heritability, but that's not the point of the study. The point of the study is to examine phenotypic relations while controlling for heritability, while controlling for genetic background. We always start with phenotypic associations. The basic tool of the field psychologist is observing correlations in the world and then examining those correlations for their causal status. BG models control for the environment as well as genes. That's sort of a nice thing about them. We think of behavior genetic models as this genetic tool, but it also controls for social class. If rich children have sex later and are less delinquent, that's a shared environmental confound of the causal relationship. So it's sort of nice to know that behavior genetics is a tool for studying the environment as well as for studying genes. Don't be literal about ACE. You know, when you have a significant A term in your twin study, it's not correct to say we've discovered something about the genetic components underlying X. So kind of get me off in a different direction. But ACE terms are domains of variance. They're not genes and environment. And more or less final message, behavior genetics is social science. Social science in general is trying to infer causation under very difficult conditions. And behavior genetics, twin studies, and really polygenic risk scores are exactly the same, is another tool in the quasi-experimental toolbox. It's no more a threat to psychology than the cross-like panel design is. It makes causality harder to infer, but that's a good thing. We want causality to be hard to infer, and we expect that most of our correlations aren't going to turn out to be causal. I don't want to repeat myself. Behavior genetics is not heritability. I'll just leave that on the slide there. I refer to genetically informal designs as the humble revolution. Enthusiasts for behavior genetics often say, you know, genetically informative designs are a game changer because they're going to show us the right way to do psychology and that we have to take genetics into account. I think that's overstated. Behavior genetics is not about finding the genetic causes of things we used to think of as psychological. It's about using the structure of twin genetics to allow us to infer causality in certain ways that we can't infer it in our ordinary data. It's treated humbly. Behavior genetics is a way of doing old-fashioned psychology with just a little bit more attention to the subtleties of causation in our data. And that's a really good thing. And it's a way for behavior genetics to be part of mainstream psychology instead of in opposition to mainstream psychology. And I will stop my screen share and leave you with that thought. Thank you very much.